Hello, my name is Bob Tipton, and this is Dark Sky Innovative Solutions presentation on our OroAzul project. This is the intro and index video, which is kind of a guide into the rest of the system and the overall claims of what we're doing, which are pretty fantastic, and you should be skeptical, especially in this industry in these times. We have all the backup videos and so forth to hopefully educate you into what we're doing and make it where you are not quite so skeptical about what we are doing and attempting to do. It's part of OroAzul is our systemic roadmap for turning fossil fuels into the fossils they deserve to be, and our plan for achieving global sustainability. During this entire effort on many sides of this discussion and research, I am finding that there are, I felt like a little boy yelling, "The emperor has no clothes," and I will probably offend, probably almost all of you during these video series at some point, no matter what side of this debate you're on, because I am finding so many naked emperors, and there is so little time left to turn the tide from the impending mass extinction. The most common division is on the left. We have what the climate folks call the deniers, who say climate change isn't real. And on the right, we have the environmental and sustainable energy movement, who says we know how, all we need is action. And as much as any of you are really not going to be happy about this, we are kind of poking holes in several of these arguments, and it begins to explain why we have made so little progress in achieving what the people on the right want to do at a cost the people on the left will be happy with. So this is U.S. Energy Administration data for 2020. You'll notice that the years kind of spot around because it's a bit tricky digging up some of this data. This is total U.S. consumption of energy for 2020. 2020 was a good year for energy consumption because of the pandemic. We weren't traveling, so the air transportation sector and the ground transportation sector were much lower than usual. Normally this number is about 100 quadrillion BTUs per year, what the folks in the energy reporting business like to call one quad. So normally we run about 100 quads. That works to be about 29.3 with a lot of zeros kilowatt hours per year. If we divide that out, we end up with 3,343 gigawatts per year. This is taking into account gigawatt hours to number of hours in the year and all the scientific notation. So where that boils down to 3,343 gigawatts for the U.S. Now it's broken out. In 2020, 12% was renewable. Of that 12%, 11% was solar, 22% was hydroelectric, and 26% was wind. Wind was producing more than hydroelectric. But remember, these are 26% of the 12%. So if you take 11% of the 12% for solar, that was 1.32%. If you take the 26% of the 12% for wind, that was 3.12%. So of total U.S. consumption, solar and wind racked up a big whopping 4.44% of total U.S. consumption. Why does that number surprise you and shock you? Because most of us are seeing advertisements all on the web, whatever, such as 50% of new generation is green. If you go back and look at the projections for 2021, 70% of planned new generation is green. So that is 39.7 gigawatts of power, and includes nuclear and batteries. It's actually including natural gas in here somehow. This is new generation. But if you add up the 31% and the 39% from this chart, you get 70% of new generation. So 70% of planned new generation is green. Well, if you take the 12.2 gigawatts for wind and the 15.4 gigawatts for solar from here, and you divide it by the 3,343 gigawatts of total consumption from the prior slide, we get 0.83% of consumption will be converted into green energy next year by the plan. This is from 2021, so that would be this year. 0.83%. What does 0.83% look like? Well, it's not as bad as you might think because it's compounded. If we take where we are today at about the 4.44%, and we project that out over time at 0.083% growth, it actually grows. By 2050, we'll be at 25%, and by 2020, 100 years from now, 2120, we'll be sitting just below 60%. Unfortunately, the Paris Accords want us to hit 50% by 2050. So we'll make about half that goal if we stay on our current track. If we double our current installation of wind and solar, we find space, we cut down trees, we clear out big fields, we level forests in order to put in the land. And there's a lot of wind going in grain fields. That's fortunate. But still, we're going to have to find places to put all this stuff and buy the batteries for the buffering. If we can double that rate, we will still fall short of the Paris Accord targets by 10% in 2050. We're going to have to go somewhere between 3 and 4 times our current installation rate in order to just make the Paris Accords. And at that point in 2050, 50% of U.S. total consumption will be sustainable, and we will still have 50% coming from fossil fuels. So putting Paris aside, if we want to end fossil fuels in our lifetimes, we're going to have to do better than this, because even if we did all of this, even if we got 8 times our current generating capacity in 2050, we would still be 85% sustainable, and the remainder would be a big chunk of that would be fossil fuels. So, what we looked at, we knew this instinctively. We finally found the numbers we were looking for. I always knew that the real problem with sustainables really is cost, is how much is it really costing industry to adopt them, and how much is it costing people to convert over. So I went back and looked at what happened between 2007 and 2019. And what happened was U.S. natural gas grew 22% over those 2 years, which works out to be about 11% per year. And that was due to total cost of the fuel, cost of conversion over to the fuel, cost of getting the fuel to the power plants, and so forth. And during that period, we got 11% per year growth compared to that 0.85 from the previous slide. So if we could achieve a sustainable energy tech that had such a profound cost advantage over existing fossil fuel tech, so that we could match that growth rate between 2007 and 2019, and with the environmental movement backing it because it's what they want, and industry backing it because it's cheap. If we can make it cheap and green and achieve 11%, we get this brown OroAzul curve, which is the projected OroAzul adoption rate, even considering that we are starting way, way, way behind. I believe we start here 3 years from now with 1% of total consumption coming out of OroAzul. But even growing at that rate, if we can kickstart it even that much and get that growth rate going, by 2050, we will be at 95% sustainable. That is a lot better than the blue curve. And that is what these videos are all about. We are about ending fossil fuels. If we want to end fossil fuels, we need to do it on price and cost. OroAzul can defeat fossil fuels, and these videos show how. Our first video is on ocean transport. The reason it's first is because it's the easiest to see what we're doing here. We have sails in the air, and we have drag sails in the water, and when these things open and close, they pull a big rope, which drives a generator, which charges batteries and other storage methods on container-sized ships out in the deep blue sea where it's wide open, and we can start building ships and deploying rapidly, and we can start generating massive amounts of power here, and we get to convert over a sector which has no answer for sustainable power, ocean shipping, which we all rely upon, not only into converting to electric over time, but actually generating power and making a new business out of their industry. Our second video is on the one I actually feel is most important, but it's out in a long, faraway place, and Americans in the first world don't quite get it. So we're doing it second. And this is indigenous power generation. Our work has shown that the tropics are the big hot spots for all sustainable energy. The sun shines brighter, the wind blows harder, the ocean moves faster. And it turns out this is also where we have the largest available low-income workforce. And part of this indigenous series is to show you how we can double and triple their income in these indigenous islands by generating sustainable energy and exporting it. In the third video, we get kind of sciencey and technical and going back into, all those classes most of us hated in college. I actually loved them, but most of you hated them, which is basic, ideal gas laws, thermodynamics, all this sort of stuff. Something that, I'm an engineer who specialized in aerospace and engines. I know these engine cards pretty well. So this is probably the most boring of the videos, but I have to tell you, this one is probably the most important, because this tells you how we can store compressed hydrogen under deep water, very deep water, at energy densities that are denser than some of the best batteries on the market, and we are storing it in cans, which last 50 years, have very long cycle lives, no lithium, no lead, no acid, no recycling problems. So if you sit through this boring video on thermodynamics, we can show you how we can store hydrogen generated by our process, which we're calling Azul hydrogen, underwater in a denser form than batteries. And the last one in the series, as we stand right now, is our deep blue sea approach, which takes what we did on ocean transport, migrates it onto oil rigs and actually anchored systems in the deep blue sea. So existing transport ships can come by and pick up the energy out in the deep oceans, all of which is currently doable with existing technologies. So this is a quick overview of the OroAzul project by Dark Sky Innovative Solutions. This is the intro and index video. I will have to warn you that these videos are not what I would call entertaining. They are intended for investors. It's a business-to-business style presentation for scientists, corporations, investment groups, and so forth. But in order to keep with our public disclosure ideals, we are showing them to you. If you find parts that are over your head, and almost all of you will, even if you're a PhD in physics, our PhD physics reviewers came back and said, well, I don't know anything about fluid dynamics. And we have got economics, we've got fluid dynamics, we've got all this stuff coming up in these videos. So almost everybody out there is going to have to go back at some point and do some brushing up on stuff they've done before. These are not easy entertainment videos. Think badly made Nova without almost the fun parts, okay? But if you dig through this to understand what we're doing, you will understand why I am firmly convinced, and some of my supporters, who include like the VP of Boeing Phantom Works, their advanced R&D group, are backing me and funding this, because those of us who work with this stuff and have dug in, we see how this can solve the problem. So thank you for watching the intro, and please dig in and start watching the other videos. Have a good morning, afternoon, or evening, whatever the case may be where you are.